Good morning, everybody. So today we are going to start with a new chapter that is called chemical bonding. Chemical bonding. Now, first of all, we must understand that what is chemical bonding. What is chemical bond? Now, chemical bond means what? It's a kind of a force of attraction between the atoms that is involved in the formation of a molecule. Whatever is the nature of the force of attraction between the atoms present in a molecule is called the chemical bonding. Okay. Now, this chemical bonding can be measurably classified in two different ways or two different types. One we call ionic bonding. All of you know this. This is nothing important. I mean, nothing important means nothing not known to you. Ionic bonding, or we also call it electrovalent bonding. Electrovalent bonding. And another one is covalent bonding. These are the major two things. There is one special type of covalent bonding is also there, which is called coordinate covalent bonding, or simply the coordinate bonding. Okay, so these are the basic things of chemical bonding. It's nothing but the force of attraction between the atoms involved in the formation of a molecule. So first, let's see what is ionic bonding. Ionic bonding or electrovalent bonding is formed between the two atoms in a molecule, okay, by loss and gain of electrons. All of us know this. It's nothing new. By the loss and gain of electrons, and by the loss and gain of electrons, they produce the positive ion and the negative ion. And this positive ion and the negative ion, or the cation and the anion, are attracted by each other by some electrostatic forces, and that is what is known as the ionic bonding. For example, let us take one example: sodium chloride. Now, whenever I'm talking of sodium chloride, if we talk about sodium atom, we know the electronic configuration of sodium atom. It has got 11 electrons. So it is 1s2, 2s2, 2p6 and 3s1. Okay. So it will lose one electron. Sodium will lose one electron and will become sodium positive, Na plus. Okay. Whose electronic why it will lose? Because its electronic configuration will be 1s2, 2s2, 2p6, so which is a stable electronic configuration. Okay. Same way, if I take a chlorine which has got 17 electrons, will accept its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. It will accept an electron. The electron that is lost by sodium will be accepted by chlorine, and it will become Cl negative, chloride ion. Obviously, the electronic configuration of this will be all this thing, and last it will be 3p6, which will also have the electronic configuration of a noble gas, which is a stable configuration. Then this sodium positive ion that is formed and the chloride negative ion that is formed will be attracting each other by a force, and that force is actually, the nature of the force is electrostatic force, and this force of attraction is called the electrovalent bonding or the ionic bonding. Okay, but before going further, let me tell you, no chemical bond is completely ionic, no chemical bond is completely covalent. So we should say them as predominantly ionic or predominantly covalent. So this is forming, sodium chloride is formed rather by a predominant covalent ionic bonding. Okay. Now, what is covalent bonding? What is covalent bonding? All of us know that when the bond is formed, means the force of attraction is generated between the atoms in the molecule, okay, by the sharing of electrons. Means one atom is giving one electron, the other atom is giving one electron, and that pair of electron is shared between the two. Then then that particular force of attraction is known as the covalent bonding. Okay, generally in case of so many elements, the covalent bonding is more prominent than the ionic bonding. Okay, so once again I am saying that it must be predominantly covalent bonding. For example, suppose if I talk about hydrogen molecule, hydrogen has got one electron in its outermost shell. This hydrogen, another hydrogen, in hydrogen molecule, two hydrogen atoms are there, has got one electron in its outermost shell. Now this will give its electron for sharing, this will give its electron for sharing, and these two electrons will be shared between both the hydrogen atoms. And that will be responsible for the formation of the bonding or for the force of attraction between the two hydrogen atoms. And in that case, the hydrogen molecule will be formed. So here this electron and this electron are given by the two different hydrogen atoms for sharing. This type of covalent bonds are called predominantly covalent bonds. Predominantly covalent bonds or predominantly pure covalent bonds, I should say. Predominantly pure covalent bonds. But suppose some certain compounds, suppose I'm not giving the example at this moment, you will understand the example whenever we'll go to the next step. Suppose two atoms are there, A and B. Now A has got two electrons, but B does not have anything to share. So A is giving its two electrons for sharing. Means these two electrons now belong to whom? These two electrons now belong to both A and B. But who is the donor of these electrons? It's A who is donating the electron for sharing. In this case, both the atoms which are forming the bonding are donating one electron each. But in this particular case, only one atom is donating the pair of electron. And the bond formed between A and B is called coordinate covalent bond. This is also covalent bond because this is also formed by sharing of electron. But this shared pair of electron is given by only one atom, not by both the atoms. That is why these are known as coordinate covalent bond. I told that is a special type of bond, special type of covalent bond, and that is coordinate covalent bond. When the shared pair of electron is given by only one atom responsible for the formation of the bond. Fine. So this basic character of the bonds, the ionic bonds and the covalent bonds are clear. Now the question is that why they are losing, why they are gaining in case of ionic bond, in case of covalent bond, why are they sharing? What is the logic of sharing? Why they are sharing and forming the bond? Okay, that was tried to be explained by certain theories. The first theory was well accepted theory was Lewis dot model. He proposed a theory. He simply proposed a theory, a Lewis dot model, where he told that they will share. He obviously talked about only the covalent bond because we are only talking about the covalent bond now. Now that the covalent bonds are formed by the sharing of electrons, and this sharing is done by the atoms just to acquire, just to gain, you can say, just to attain the electronic configuration of the immediately closed noble gas. Okay, it wants to take the immediately closed noble gas, okay, electronic configuration of that, and that gives it the extra stability, and that is why they are sharing the electron and forming the bond. Fine, that was the concept. Okay, now let us just see that how did he explain his concept. He explained his concept by a simple process called Venn diagram method. Okay, for example, suppose, let me just do few, then I will give you some homework. Okay, for example, suppose hydrogen is hydrogen molecule. Okay, so hydrogen molecule, how we can explain it by Lewis dot model, Lewis dot model or Lewis dot method, where the each atom's valence shell electrons are drawn by dots. So hydrogen has got only one electron, and that is the valence shell. So hydrogen is drawn by like this, hydrogen a dot. Another hydrogen atom is there that is also drawn by H, dot. Now, Venn diagram. Each atom in the chemical bonding should be represented by a circle. Okay. So here the hydrogen will try to gain the electronic configuration of the closest noble gas. The closest noble gas of the hydrogen is obviously closest means I don't want to say closest in terms of the periodic table. The immediately next you can say. The noble gas is what? The immediately next noble gas is helium, which has got 2 electrons. So each hydrogen will try to have 2 electrons in it and that is possible only if these 2 electrons are shared. Means this hydrogen will use both the electrons. So I am drawing a circle with this hydrogen. This hydrogen will also use both the electrons. Okay, so I am drawing another circle. So you know this. This is the intersection of the Venn diagram. This part is the intersection of the Venn diagram, which is actually common for both the hydrogen. Common for both the hydrogen means what? It is being shared. Okay. If one pair of electron is shared, as it is happening over here, we call it single covalent bond. And we represent it by a single dash. We write it like this, H dash H. Okay. If we try to explain O2, O has got 8 electrons total and hence in valence shell it has got 6 electrons. So according to Lewis dot structure, we are just drawing the valence shell electrons by dot. So we are going to draw 6 dots with each oxygen atom. Fine. So oxygen atom 1, 2, 3, 4, 5 and 6. Another oxygen atom 1, 2, 3, 4, 5 and 6. Now it wants to become 8 because octet, that's the electronic configuration of the noble gas. So how it can become 8? If it takes or if it uses these 2 electrons from the other oxygen atom. Same way this oxygen has got 1, 2. Okay, let me just draw ones as dot, ones just for you understanding, but you must draw it by dots only. Okay, this one. So now this also wants to become 8. So this will use the 2 electrons of this. So how many pairs are common? There are 2 pairs which are common. 2 pairs are common, right? And these 2 pairs of electron, if it is shared, then we call that covalent bond as double covalent bond. And we represent as O double bond O. Okay, 2 dashes. Okay. Same way, if I try to draw N2 nitrogen has got 7 electrons in its valence shell. So 7 electrons in total, therefore 5 electrons in its valence shell. So if I try to draw the Lewis dot structure of nitrogen molecule, it has got 5 electrons in its valence shell. 1, 2, 3, 4, 5. Another nitrogen has got 1, 2, 3, 4, 5. It wants to become 8, so I am taking 3 from here and giving it. Okay, it's shared. It also wants to become 8. I am taking 3 from here and giving it. So how many pairs are shared between the 2 nitrogen atoms? It's 3 pairs which are shared. If 3 pairs are shared, that is a triple covalent bond. So covalent bond can be single, double or triple. Okay, depending on the number of pairs of electron that is shared. If 1 pair of electron is shared between the 2 atoms, we call it single covalent bond. If 2 pairs are shared, we call it double covalent bond. If 3 pairs are shared, we call it triple covalent bond. Just like that, we can draw some more. Okay, for example, suppose if I draw CH4. Okay, CH4, carbon is the central atom. The Lewis dot structure of CH4 simply. Carbon is the CH4, the carbon is the central atom. Okay, so carbon has got 4 electrons in its valence shell. Hydrogen has got 1 electron each. There are 4 hydrogen, 1 electron each. Okay, and obviously hydrogen wants to get 2, hydrogen wants to get 2, hydrogen wants to get 2, hydrogen wants to get 2. But the carbon is becoming how much? The carbon is becoming 8, So how many pairs are shared between this carbon and this hydrogen? You can see this carbon and this hydrogen, only 1 pair is shared. This carbon and this hydrogen one pair. So each carbon and hydrogen is sharing each one pair each. So the nature of the bonding over here is C, single bond H, single bond H, single bond H, and single bond H, right? And this compound, is called methane. So like that, you have to draw the Lewis dot structure of the other compounds. You have to practice this little bit. Okay, if you are expert with the Lewis dot structure, then we will see that whether all the compounds in the Lewis dot, in all the compounds or all the covalent compounds or all the predominantly covalent compounds, can they be explained by Lewis dot structure or not? Okay, that we will see in the next class. Okay, so hope you understood how to draw the Lewis dot structure. Now it's your time to practice the Lewis dot structure of many compounds. Okay, whichever are there in the book. Please try it. We will discuss about those tomorrow. In the next class, and then we are going to see it that which compounds could not be explained by Lewis dot structure and how can we rectify that. Thank you. Have a nice day.